Hello everyone. I would like to welcome all of you joining us for the webinar today on the asset integrity with comprehensive materials and structure analysis, brought to you by Element Materials Technology. We will start the webinar now. At Element, our mission is to make tomorrow safer than today for more than 60,000 customers spanning various industries. Our journey has been marked by remarkable growth, with a total of 51 acquisitions, including 3 in 2023. Our accomplished experts have secured over 1,000 accreditations and approvals, actively engaging in the development of global standards. Through our commitment to safety, quality, and performance, we strive to contribute to the advancement of a better world. Together, we help our clients to develop better products, improve time to market, and help our customers become more efficient through the collective experience and knowledge of our team of over 6,000 engaged experts. Today, it is my pleasure to introduce you to our presenter, Dr. Basab Bhattacharya. Dr. Basab is the technical specialist at Element Materials Technology for Energy MEAP. He graduated from the Indian Institute of Science and holds a PhD in Materials Science and Engineering from McMaster University.
Thanks, Stan, for the warm introduction. At first, I will outline our agenda for today. We'll start with the fundamentals of asset integrity, followed by its purpose and values. We will then present a case study that outlines the detection of crack, characterization of their growth, and subsequent modeling to predict the remnant life of the asset. The case study we have chosen today is on corrosion under pipework support. It is a very interesting one and is a parcel issue in the energy industry. So I hope you will like this case study, which is a very interesting one. At the end, we will conclude with some key takeaway, and we'll have some time for question and answer. We will begin the seminar with some definition. What is as integrity management? This slide presents three definitions from renowned organization, PWI, the American Institute of Chemical Engineers, and then Institute of Asset Management. We can summarize by saying that asset management is a systematic approach of ensuring reliability, safety, and efficiency of physical asset, which optimize the business performance and its profitability. In all countries, government regulation mandate that asset owners maintain diligent oversight of their assets to ensure ongoing safe operation. Regular inspection are crucial for asset to identify potential hazards and determining the remnant life of these assets. These assets provide valuable assessment provides valuable insight, enabling efficient planning for asset utilization, maintenance, and operation. Effective asset management allows organizations to optimize resources, reduce cost, and minimize downtime. However, this asset management or asset integrity process can be very expensive and time consuming. So there are opportunities to bring down the cost and time of this assessment, which increase the probability. It gives us opportunity to innovate solution, may improve the inspection process, analysis process, or do some high-end analysis which gives long-term solution. For example, one of the solution is real-time collection of data and analysis, which provides actionable insight and gives us insight of how to improve the performance of the asset in real time. We will now delve into the asset management process through a case study, which will focus on corrosion under pipe support, providing a practical understanding of effective asset management in action. During a routine site inspection, corrosion under pipe support was identified beneath a pipe support. A site investigation was done, pinpointing the location and extent of corrosion. Our Singapore team then conducted a site visit, performed non-destructive testing to assess the condition of the affected area. Samples were also extracted from the critical location with due permission from the asset owner and sent to our lab for analysis to determine the root cause of the failure and the mechanism of corrosion of this asset. Results from both on-site and in-laboratory testing was utilized as input data for digital engineering team in UK who did the modeling and simulation to predict the remnant life of the asset. This provided our client a comprehensive assessment of this asset's integrity. So we start with the part one of the process, which is inspection, detection, and classification. The initial phase involved conducting a thorough inspection accompanied by photographic documentation. The collected data was meticulously analyzed to pinpoint most critical areas requiring further investigation. It shall be noted that Element has established a partnership with one of the partner who are specialized in advanced data capture technology. They utilize laser cameras to rapidly collect the data, which was then processed using artificial intelligence technology. This innovative approach enables us to quickly analyze the data with high accuracy and which provided wealth of insight within an extraordinary short period of time. After identifying this location, it was our responsibility to confirm the severity of the corrosion or damage, and it was also necessary to determine the mechanism of damage. This slide will elaborate on the damage mechanism and investigation through the following analysis step. So, our investigation started with visual examination by our team, NDT team. This was followed by non-destructive testing according to our standard procedure. Subsequent to the NDT and visual examination, we did metallographic examination, on-site metallographic examination, and then we decided to take samples from critical areas of the asset for further analysis and lab-based testing. After analysis and testing, we provided a comprehensive report to the client which summarizes the finding and determine the condition of the asset and type of damage. The visual examination revealed heavy corroded area, as you can see in the slide, 4 different pictures. Some areas through hole was observed. So initial observation of the surface concluded that there is mostly a surface corrosion, and this could be due to exposure to the seawater. Visual examination indicated the corrosion was primary at the surface level with no sign of extensive internal damage. However, further analysis was required to confirm the preliminary assessment. Presence of corroded surface under insulation suggested that seawater may have contributed to this corrosion. Inspection finding highlighted the importance of adequate protective measures such as coating or cathodic protection under marine environment. Further investigation was carried out to understand the severity of the corrosion. A thorough NDT examination was carried out using MPI, dye penetrant, and ultrasonic testing. Some areas we have seen through holes, as I mentioned previously. We have done fluorescent magnetic inspection, which says severe presence of corrosion at the surface. We also have seen during UT through thickness crack inside the material. So initial investigation, NDT investigation suggested that surface corrosion is primarily is the main corrosion problem of this asset, and also there was some through thickness crack presented in some location. To assess the condition of the asset, we have also done replica analysis in several locations of the pipe. We have mostly found the structure is as per the expected structure of the material, microstructure of the material. However, occasionally large grain size was found in some location, as shown in the right bottoms of the picture. However, these grains didn't contribute to any failure of the structure, and these were only occasionally found in one or two locations. A complete hardness test was done. On-site hardness test was conducted, and there it appears that the hardness value was as per the relevant standard, which further confirmed the integrity of the material. So in summary, on-site replicant hardness test suggested that material of this asset is in good condition. There was no sign of significant deterioration or degradation of the material during this operation life of the asset. After doing this on-site testing, monitoring the health of the material, it was also necessary to understand the forces acting on this asset during operation, because the data was not present with the customer. However, this data was very important for further remnant life assessment. So after doing replica and metallographic work, strain gauges was installed at different critical location of the component, and the strain versus number of cycle was collected over a period of 1 month. Now this particular section, particular data was very useful data, which gives us dynamic stresses imparted on the structure during the operation. And this data was fed to our digital engineering team, who used this as a valuable, crucial input data for their remnant life assessment. As I mentioned before, we have taken some sample with due permission from the asset owner for further analysis to our laboratory. So we have done an extensive in-lab microstructural analysis. There was no anomalies found in the microstructure. However, pits observed in the microstructure, and it was observed during ACM observation as well. Analysis of the corrosion product was done, and it was observed that chlorine was is present in that in this impurities. So it confirms that corrosion is related to the exposure of chlorine, and which caused uh, pitting of the material in localized pitting, and this is the main cause of failure corrosion mechanism in this material. We have done further analysis of the component where through thickness crack was observed during UT measurement. Detailed analysis was done, and it was observed that this particular crack actually initiated from a pit location, and due to applied stress, this has propagated through the material. However, there was no issues observed with the material, and as I mentioned before, both mechanical and metallurgy property complies with the specification of the standard. So in conclusion, the part 2 of the analysis, we can say that cups observed in the pipe surface, a microstructural scopic examination at the lab confirmed the presence of peat, and there was also observation of chlorine on the surface in the lab-based observation, which confirmed our observation or speculation. We also done microscopic examination and saw that there is a through thickness crack which is formed originated due to peat. And then this data for mechanical test and metallurgical analysis was supplied to our DE engineering guy, digital engineering people, and who used this data for further remnant life assessment using finite element assessment. This brings us to the part 3 of this analysis, which is fit for service analysis. The data from material testing, which was collected during on-site and in-lab analysis, was used for further finite element used as finite element analysis to do in-service remnant life assessment. The fit for service assessment or remnant life assessment was performed as per the industry standard. We have used advanced finite element software to facilitate this analysis, and detailed modeling and simulation was done to simulate the accurate operation condition and the corrosion condition of the pipe. By leveraging our capability to do on-site testing and to do materials finite element analysis, to do fit for purpose analysis, our client got enough information to get to decision about maintenance, repair, and replacement of the critical asset. We will now discuss very briefly how the simulation and analysis was done. The typical material data, material loss data, geometry, material property, and the on-site loading data was used for as input data for the analysis. It was also the condition of the corrosion, the material loss, the depth of the pitting, everything was used as input data for this analysis. Dynamic loading condition was simulated in the structure to perform this analysis. It was also the data for operation condition, worst case operation condition were also obtained from client, which acted as a input data for analysis. The advanced level 3 579 part 1 level 3 type of analysis was conducted, which is actually recommended by this standard for such situation. This type of analysis allows us to simulate the actual condition of the pipe with multiple damage, and by this analysis we have able to find out what is the impact of this crack present in the material, what will be the impact on the remnant life of this pipe, of these structures. We then we have then put this data into a risk matrix and did an analysis to find out the start of the life and end of the life cracks dimension. Our analysis, detailed analysis, showed that some of the cracks, some of the crack or pits present at the start of the life will be very near to the near to the critical zone of the material at the end of the life, and there will be some which will be still at the safe zone. So this helped our customer to decide which areas to be first looked at, and what protective action, preventive action our client may take for this type of analysis, for this type of structures. So a decision can be made using risk-based approach, and this helped our customer a lot for future maintenance and inspection. So to summarize, this case study provided an innovative approach, which by doing high-end inspection, testing, and high-end analysis, which helped our customer basically to reduce cost of maintenance. It helped them to understand which areas to be looked first at the beginning, which areas are critical, and this helped them to enhance the quality of the structure, help to reduce risks, and all this thing can be done with a one-stop solution through our services in Element. At the end, I like to highlight that code and standard used for this type of assessment are already well established in the industry. There's nothing we are inventing. These are all well established, and they give guideline to us to do how to do risk assessment or fit for purpose analysis for different structure, pipe, or some offshore onshore equipment. This is where I like to end my presentation, and if you have any questions, we can answer this.
Thank you very much, Dr. Basab. Some great insights there. It looks like we have actually got quite a number of questions that are coming from our audience. So I'm going to start going through some of these questions for you. What software was used for FEA?
It was done in the Element Cambridge laboratory. Mainly, they use Abacus, or they have their own inbuilt code which they use for this type of analysis.
Next question. Will today's presentation include discussion of API standards that apply to asset integrity management?
Yeah, actually, the analysis referred to API 579 in several cases. So basically, it is a API 579 level 3 type analysis. Yeah, it includes this standard. If you have any specific question, you let me know on this standard.
Yeah. Thank you, Dr. Basab. Next question. What strategies would you recommend for preventing pitting corrosion in industrial assets?
So normally, if there is a problem of pitting corrosion, if we foresee a problem of pitting corrosion, proper use of material is quite recommended. This is basically one aspect. Then you can apply coating, but mainly what is done is for seawater condition you use proper material. Obviously, the best material is super duplets, but if it is costly, then you go for duplets, and then if there are less severe condition, you can use other material, but mainly duplets or super duplets. Use of proper material is the main answer, and obviously you can use protective coating and all that, but this is secondary.
Yep. We have other question as well. How do you correlate data from non-destructive testing with actual material degradation rates to predict remaining useful life?
Well, okay. This is a okay big question actually. If you how to correlate data from non-destructive testing to the actual material degradation. Obviously, when you do NDT, the information you get mainly is on the surface flow, or there is by ultrasonic you can get if there is a through thickness flow. Also, you might get the material loss data, which is corrosion loss data. So all these data are useful, and then you can do analysis to see whether this material will be able to withstand the applied operation force of the operation condition. So this is how you can do. Another thing is, if you want to really correlate the data, you want to quantify the data, you might have to do some calibration of the NDT equipment with the actual corrosion loss. You want to see if your NDT equipment is giving you quite accurate data. It's not a big problem if it is a flat plate, but the problem comes when it is a complicated structure. So, but thing is, this type of procedures for NDT equipment is quite common, especially when you are using UT, which is actually giving you insight through thickness data. So this type of equity, NDT, PAUT or UT equipment, often validation is very much required.
Okay, we have another question. What advancements in material analysis technologies are proving most valuable for identifying early stage fatigue cracking in critical components?
So early stage fatigue cracking it is a surface cracking. So you might do intermediate inspection using PAUD, surface crack or UD. Then you have surface crack. Then you can use surface inspection method like DPI, NPI, even AD current method. You can do and see whether you can get the crack data. You can detect the fatigue crack data, but it's basically usually you cannot do this fatigue. If we are talking about fatigue, mostly it is in the operation condition like a shaft and all that. So you might have to do go for shutdown and do this analysis. So intermittent inspection is highly recommended, especially for fatigue sensitive areas.
Okay, we have one more question here. What standards and methodologies do you recommend for ensuring the quality and reliability of automated inspection data?
Well, automated inspection is something you can get the data, but qualities and standard they remain the same. Like there is API 581, 580, 570 for damage control, 597 for assessing fit for purpose assessment. But at the end of the day, there is, if you want to do automated inspection like NDT or automated data collection for laser photography, all these things remains. There is no particular standard as I am aware, but at the end of the day, you can collect the data, use the normal standard.
Thank you very much, Dr. Basab. We will now conclude the asset integrity webinar today. Thank you very much, everyone, for joining, and have a good day.